This video is a demonstration of the law of conservation of mass. And what we're looking at for our setup is a beaker filled with an acidic solution, and then an Erlenmeyer flask filled with an acidic solution, and then we have a balloon filled with baking soda, which will react as a base. We're going to form an acid-base reaction, and it's going to convert a lot of the mass inside of that liquid and the liquid acid solution and the solid baking soda. It's going to convert a lot of that mass into a gas, specifically carbon dioxide gas. But what the law of conservation of mass tells us is that in a closed system, and I've closed this system by placing a balloon over the top, which should not allow gas or hardly any gas to escape. Even when a chemical reaction occurs, the total mass before and after that chemical reaction should stay the same. So right now we're looking at a mass of 192.6 grams, and I'm now going to pour the baking soda in. You can see the balloon is inflating due to the reaction, but very, very little of that gas is escaping. You can see slowly some gas is leaking out the sides of the balloon, but the mass is hardly changing at all. And later I will show you what would have happened if the balloon had not been there to conserve that mass. So here we're looking at the exact same chemical reaction, but without a closed system since there's no balloon on top of the Erlenmeyer flask. I still have a citric acid solution in the Erlenmeyer flask, and I still have the same volume of baking soda that was in the balloon. But we're going to react these without the balloon, and we'll see what happens with the mass, since a lot of this mass is again being converted to gas, but now there's nothing to keep the gas in the beaker. It's important to note that before I set these on the scale, I taired both the Erlenmeyer flask and the graduated cylinder, so those weights are not being included in the reaction, but just to keep everything the same, I'll make sure that the flask, the beaker, the graduated cylinder rather, goes back on the scale after I pour in the solution. So let's look and see what happens. The mass right now is 151.7 grams. So we're reacting the baking soda. A little bit of spilling over the top, not too much. And you can see we've already lost almost 10 grams of mass to the gas. So we're losing mass a lot more quickly than we did when we did the experiment with the balloon over the top. One thing that's kind of cool is this beaker is still filled with carbon dioxide gas, even though you can't see it. But I should be able to get rid of a little bit of mass just by pouring out the gas. So I'm not actually pouring any liquid. I'm just trying to pour some of that invisible gas out. And it should drop quite a bit from where it was. I don't know if that'll work or not. I'll have to double check the data. But there you go. That's the reaction with and without a closed system.